Okay, everyone, so we'll start now. And just want to confirm if my screen is visible. Anyone can just unmute themselves and let me know. Or, just type in the chat box if my screen is visible.
Yeah, but it's visible. Like you can see on the chat box, students are not text over there.
Okay, great. Thank you so much. Okay, so we'll start with the session. So basically, like I mentioned in the message, today's session is an introduction to machine learning. So we'll just go through the basic topics first. What is the different topics that we want to see? So the first topic that everyone needs to know in machine learning whenever you're trying to learn is something called a basic machine learning pipeline. Okay. Now, I don't know if you all know the meaning of the word pipeline. Pipeline basically just means that a sequence of steps performed to get a certain outcome. Okay. So basically, you perform these sequence of steps. That means you perform these steps one by one in a specific order mentioned here, and you will get a good and decent output for whatever machine learning or deep learning model that you're creating. So let me just go through the steps one by one, and we'll go to the next parts then. So the basic machine learning pipeline, like it's written here, first step and the most important step that we need is data collection or data extraction. So whenever we are training a machine learning model or trying to create a machine learning model, the first and the most important thing that we need is something called data. So this data that we have is using which we train our model and we test our model and we can decide if the model is good enough or not. So for data collection and extraction, there could be various methods. You could scrape a website, or you can use some database. You can use predefined data sets in CSV file formats. So we'll discuss about that as well, what a CSV file format is, and that. So then once we have the data set with us, then we go to the next step called data munging or data cleaning. So, like I mentioned before, when we have data with us, it is not necessary that the data is clean. Sometimes the data contains unnecessary information which is not useful for us. So, we need to get rid of that. So, trying to clean our data set from useless information that would not help us in training the model is called data munging or data cleaning. And once we clean the data, we have a clean data set, we can start performing data pre-processing on it. Okay, so if I just come and tell you what this looks like. So as you can see here, guys, this is a basic data set that we have. This data set, it basically looks like an Excel file itself, and this file is called a CSV file, which is a comma separated value. Okay, so if you just see if you can see here, you have the test data, the train data. This is just a basic example that I'm showing you of a data set, what a data set actually looks like. So then here, if you can see, it's written here Microsoft Excel, comma, separated values, that is dot CSV files. So these CSV files can be opened with these Microsoft Excel as well. That's why it is open with Excel. You can open it with Notepad as well, and various different things. So this is just an example that I'm giving you. So this we've opened the test data. We can also open the train data, not a problem. Usually the data set that we get, it contains the whole train and test in one example itself. They are not separate, but here it is just given separate. Mm, okay, cool. So yeah, so in this train data, if you see, we have here is we have different rows in horizontal direction and different columns in the vertical direction. Okay, I hope you all know what horizontal and vertical are. So these columns that given here A, B, C, D are columns, and 1, 2, 3, 4 are rows. Okay. Now there are important keywords that need to be understood here. If you all need, you all can make a note of it. The columns in any data set, they are known as features or dimensions. You will see these words a lot being used in future. So that's why it's an important thing that you all know these words. So all the what do you say, columns, they are known as features or dimensions. Okay. So you have your 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So you have 13 columns or 13 features or 13 dimensions in this data set. And these different rows that you'll see, 1 2 3 4 5 6, they are called samples. Okay, so these different rows are called samples. And if you just want to look at it, how many samples do we have? Is we have 6020 samples in this particular data set of a used car prediction. Okay, used car price prediction. So this data set has 6020 samples in it with 13 dimensions or 13 features. Okay, so this is basically how a data set looks like, which we will be using a lot in future, and you will also be using a lot for your projects and different things as well. So I just showed you what a data set looks like, and I told you about munging, cleaning, pre-processing. Now, pre-processing, when we talk about, there are various different things that we need to do in pre-processing. I'll come to that as well. You all will understand all of it. So when we talk about pre-processing, there are different things that you need to do, like data scaling. So in data scaling, you have standardization, normalization. You need to scale the data in a scale which is common to all. So this is data pre-processing. There are different methods of that as well. And once that is done, then you come to feature engineering or feature scaling. Again, scaling here is like normalization or standardization, like I mentioned. Standard scaler, normal scaler is also called as that. And feature engineering. Now, like I mentioned, the data set, there are different columns. And what did I say? Those columns are known as features or dimensions. So here you have is feature engineering. So if I just come and tell you, in a basic idea what feature engineering is all about, is if you look at this car price prediction data set that you have right here. Okay, it's a very basic one. If you just look at this data set, you will see that the data here is in different formats. You have words here, you have numbers here, then you have numbers and words here in a single cell. In all these cells, numbers and words. Now you tell me, do you think a machine will understand what words are in a data set? Of course, it will not understand what words are in a data set. Machine is not built to understand words like how human beings are. Machine can understand only numbers. So there are different methods that we use to convert these words into numbers, and that is called encoding. So you have categorical encoding, one hot encoding. So you have different terms like these as well. We'll come to that also in future. And like I mentioned here, we'll come back to feature engineering that we have right here. Okay, so if you just look at this data set, you have a column or a feature called location, which has different locations here. Okay, now when you're trying to train the model using all of these parameters or all of these features or dimensions, most probably there is a high chance that this location might not be a very contributing factor. Okay, this location might not be a very contributing factor for the model to learn the prices of the cars available here. There are different factors that affect the price of a car, right? Which could be like the engine, what cc the engine has, how much bhp, the horsepower the engine has, the mileage it gives, the transmission, and whether if it is a first hand, second hand, okay, fuel engine type, and how many years old the vehicle is, how many kilometers it's driven. These are the different factors that can affect the price of a car, right? But well, do you think a location might affect the price of car as much as these other factors do? No, it will usually not be as effective as the other factors here. So here, location is a feature that could prove unnecessary for training the model. So to get rid of this feature called location, we perform feature engineering. And not only location, we have the name of the car as well. These names of different cars. Usually these names also will not matter as much because it just doesn't. Usually it doesn't. So location and name usually are the two different features which will not help in trying to predict the price of a car. So these features need to be get rid of, and this is known as feature engineering. Okay, so we can do that as well. And when we perform feature engineering, is we are reducing the features, we are reducing the columns that the model has to crunch. Okay, here we've come across another keyword. So a computer crunches numbers. That means it is constantly performing different algorithms on these numbers and trying to derive results. So when it does that, it consumes a lot of time. So when you are trying to reduce these two columns itself from a data set, you're reducing 6020 samples of two columns. So it's a big reduction for the model. Okay. So when you do this, you reduce the time of the model, because any which ways these two columns were not proving helpful in the training of the model, right? So this is feature engineering. And then you come to data visualization. So here also it's very important. When you do data visualization, you understand various different things. You can do different graphs. You can see how many outliers are there in the data. We'll come to outliers as well, what they are and all of it. And you need to get rid of the outliers. And you can understand how the distribution of the data is, if the distribution is normal, or if it is left skewed distribution, right skewed distribution. All these are different keywords, so you all can look it up anytime. We'll go to that anyways in future. And once you do that, you will understand how the data is and what different algorithms or steps you need to perform on the data. And then you have this data pre-processing. Like we mentioned before, it's the same. Just written it again. After data visualization, also sometimes data pre-processing may be required if you have missed it in the past. So you can do that here as well. And by doing data visualization, you will understand which kind of algorithm that you need to use. If you want to use a regression algorithm, classification algorithm, if you want to use a neural network, if you want to use k nearest neighbors or clustering algorithms, you'll understand all of that by doing data visualization. And then you can import the model from the different sklearn libraries. So there is a library called sklearn. You can import linear regression or logistic regression, etc., different algorithms from there and apply that. And then you do the model training. Now, okay, so let's just come back here. So I've opened this used car price prediction dataset itself here with the solved complete example. So my screen is visible, right, guys? Can you all just let me know? Yes. Okay, great. And I hope I'm pretty clearly audible enough, right? Okay, great. Excellent. So right now we are on the used car price predictions. Okay. So here, the first step that we need to do in any data set while solving any data set or a machine learning problem is we try to import the different libraries required. That is the beauty of Python. Okay. So now I understand many of you might be having a doubt that, bhaiya humko Python nahi aata, just say we didn't learn it any time before. It's the first time or we are just beginners or anything. It's fine. It doesn't matter at all, because what codes used in machine learning are 99% same all the time. You will remember it and you will understand it. You don't need to be a master in Python or anything. It's very basic. It's very simple. There's nothing in it. So first of all, let's come here. So basically what I've opened right here, let me just start with that. So what I've opened right here is called a Jupyter notebook. Okay. Now Jupyter notebook, Google Colab, all of these are same things. If you all know machine learning, some of you all use, you all might be knowing what Jupyter Notebook is, what Google Colab is. For others who don't know, I will just make you understand in short what it is. So basically, a Jupyter Notebook is something that every single data scientist or a machine learning engineer uses in his day-to-day career. So let me just tell you, you all can see the different codes written here, import statements, and you all have something called one written here. And then you all have one more new rectangle here, test train written with two written on the left hand side. So each of this is called a cell. Okay. Each of this is called a cell. Each of this rectangle, see this whole rectangle is called a cell. This rectangle is called a cell. Every single year of these rectangles are called cells. Now cells can be of different types. You have code blocks, cell can be a code, or cell can be a markdown. Obviously, when I say a cell can be a code, that means that you can write a code in a cell and you can execute it and you will get an output. And when you have a cell which is a markdown like this right here, that means it will be an cell of the format of HTML and CSS. That means you can have notes in it. You can just give a basic notes that what the cell is all about. So like right here, if I want to add a new cell, I will click on this plus sign here. A new cell has been added, and I want to just write in my cell that what these import statements are, what are we doing in this step, I can just have a short introduction or short explanation on what I'm doing here. So I will come to the cell, select the cell first, and I can come to where it is written in code, select markdown. Now this cell has been converted to a markdown. It is no longer a code. Okay, I can write anything I want in this and it will turn into a markdown. So I can just say these are the import statements. Now there are different beautification styles that we have here. If you just put a hash and space, it will become a h1 tag. And how do you execute this? You can either, just click on run, or you can hit control and enter, and this cell will get executed, right? I hope there are no doubts, right? If there are any doubts, please unmute yourselves and let me know. Okay, cool. So this is the first we have done. I told you what a Jupyter Notebook is all about, and like I mentioned, even Google Colab is the same as Jupyter Notebook. There is no difference at all. Okay, only difference is that Jupyter Notebook uses your own machine, the resources like CPU or GPU if you have. The Jupyter Notebook will use your own machine, but the Google Colab will be connected to the CPU and GPU provided by Google. If you are lucky, you may get a GPU as well, and you can use that for your training processes. So that's fine. So right now we've come to the first code block here, which contains all the import statements. So we will see each and every library here in detail later, not now. There's still time for that. We'll come there later. So first is we have the import statements where we import different libraries. Now here as well we have a keyword called alias. Alias, let me just spell that out. That will be like alias. Alias. So this keyword that I've written here, alias, what it is, let me just tell you all that. So this code right here is import numpy. Numpy is the name of a library, and then we're writing as PD. Now when we're specifying it as PD, as NP, what does this mean is that we are trying to give an alias for the library named numpy as NP. That means we are trying to, every one of you all might be having pet names given by your friends. Like my pet name given by my friends is something called Tommy. I don't know why. So, Tommy is a short form of Brian Thomas, a whole big name. So here, instead of writing numpy every single time you're calling this library for use, you can just type np. So this keyword right here is alias. So remember that as well. It may be used in future. For your understanding, you all can understand it. So import numpy as np means you're using an alias for the library numpy. Same goes for pandas as pd, and same goes for matplotlib.pyplot and cborn as well. So since we came here, we were at the, what do you say, yeah, model training and all of that. So let's start with data visualization. We'll come to that. So if you all have a look at these libraries mentioned here, you'll have matplotlib.pyplot and cborn. These two libraries are used for data visualization. Using these two libraries, we get to, draw different graphs and understand how the data looks like. So okay, we're done with that. Let's come to the next cell. Here we have two different files in this folder, right? We have this Jupyter notebook, which is called the IPYNB file. Okay, this is called the Jupyter notebook file. And then we have the test data and the train data, which are of the formats .csv. So right here, when we open a Jupyter notebook, we need to load these data sets into a Jupyter notebook, and then we can use them. Okay. So how do we load is that we load it using the library pandas. So we are calling these pandas as PD using this alias, and we're calling a function called read CSV and passing the parameter of train data dot CSV. That is, we're passing the parameter, the name of the CSV file that we have in the same folder. Okay, so we are passing a variable. We are using a variable calling the library pandas, the function read CSV, and passing the parameter train data dot CSV. Okay, and we're loading this data into a variable called train. Same goes for test. So you'll understood how the data set is loaded into a Jupyter notebook. For Google Colab, it is much more similar. It is not simpler, it is quite similar. So Google Colab, how it works is that it works on Google Drive. So every single data set that you have, whatever Jupyter notebook that you create in a Google Colab, it's stored in a Google Drive. So you can access it anywhere in the world, on your phone as well, on your different machine. If you make the Google Colab at your personal machine, you want to access it from college, you can do that as well. That's not possible in a Jupyter notebook, but so that's the basic difference between Colab and notebook. So after we've loaded the dataset in this variable called train and test, we want to check how the dataset looks. So we type a code called train.head. Now, when we are typing train.head, we just get the top 5 samples of the whole dataset. 0, 1, 2, 3, 4. That is 5 samples. If you'll count from 1, there are 5 samples here. So we have all different features here, 5 samples of each feature in train.head. Okay. Now what if I just type train? What's going to happen then? If I just type train, what's going to happen? It's going to try and give out all the results. How? It'll it'll give the first 5 samples, dot, 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 and last 5 samples. Obviously, it cannot print the whole data set here itself. It's going to take a lot of your computing power. So that's fine. You can try all of this later. So you have train.head, train.tail. Okay, all of these different functions you'll have. And our very important code that we have is train.info. This gives us a lot of important information. Okay, so I'll have here is 6019 entries. That means you have 6019 samples in your data set, and you'll have 13 columns in this data set. So it gives the column number, column name, and how many what do you say, non-null count is there. That means how many data that you'll have is not a null value, and then the data type of each column, if of each value present in a column, it's written here. So the first column we have is name. We have not a single null value. That means every single value is completely full, and all the values are of type object. That means they are string objects. Okay, objects basically comes under string, or different objects other than int or float. They are objects. So you have name, location, which are words, so they come under objects. Years, kilometers driven are numbers, so they come under int 64. Again, fuel type, transmission, owner type, mileage, they have the numbers as well as letters in them. That's why they convert to, see, fuel type, transmission, owner type, mileage, and CC has these words as well as numbers, hence they become objects. Then you'll have seats, new price, etc. etc. Important thing to notice, see these values here, non-null count type, everybody will have 6019, but here the number is different, it's much lower. That means what? There are null values present in these different features. So these null values, this problem needs to be handled. Okay, so we'll come to that as well. And yes, this was a train data set. We were trying to check all the different values, and here we have the test data set. Okay, and in the test data set, so if you look, we have the same thing here, but the different thing is that the price section that we have, that is the most important column in this data set. It has the least number of values which are not null. Okay, so it's a big problem. So let me come back to the data set. I'll just try and make you understand in short what this is. Okay, wait, I can do that here itself. Okay, so if I'll just look at this data set, very important thing I'll mention to you all, I did not mention earlier, is that we have different columns. Okay, the most important column that we have right here is a column called price. This price column is the column which has the price of the cars which are used with all these different parameters. Okay, so when we train our model, we train our model such that it has to learn, it has to generalize the prices of these cars with these parameters, so that in future when we provide a car with different parameters to it, it can predict the car's price. Okay, so price is a very important feature that we have here, and if the price feature itself not present, we are having a lot of useless data. That means we need to either change our data set or try and manipulate our data and generate some samples in our data set. So here we have the price, which is the most important feature, like I mentioned. Okay, so we check that as well, no problem. And yeah, now we come to the important part is where we're trying to check how many null or nan samples are present in the training set and the testing set. So if you all know what null samples are, null samples basically mean is that zero sum, the cells which have values of zero in them, or cells which don't have any value in them. It's empty. Those cells could be empty. If you all see here, see these cells right here, and this the first sample that we have in the new price feature or column. See these cells, they are empty. Hence they become null cells, null values. Okay, and then we have the nan values. Nan means not a number. Nan is a short form of not a number. So we check for these values as well. In the train data set, how many, what do you say, we have the nan values and sum. So if I just show you all, if you just try and run this function train.isNA means you're checking is the value have NA in them. That's a function. Okay, train.isNA. So here you will get all the columns and you will get true or false in every single column. Now you cannot manually sit and count, right? How many columns, which true and false, how many, different. It's crappy. So we have another short form for that called dot sum. So when we perform dot sum, it actually gives us a what is summation of all the values. So in the name and all of these different features, we have zero null values or nan values. But here in these all features, you have a lot of null or nan values. Sorry. In the new price especially, see we have the number of nan values are 5,195. The total number of samples we have is 6,019, and उसमें से 5,195 itself are null values. So it's such a useless column. We need to get rid of it. It makes no sense. It helps us in no way because it's so empty. It will not help us training the model at all. So when we perform all these different steps, we get this inference, we get to a conclusion, we can take appropriate steps and save our time, Otherwise, when we train a model, we test a model, we'll see the accuracy is so low. Why is it? Then you'll backtrack and then you come back to it. No, it's all useless. It's going to take a lot of time. So better than that is you perform all these sequentially and you will get to an optimal model during training and you'll save a lot of time as well. That's why it's called you follow a specific machine learning pipeline. Pipeline is a sequential, steps the way you follow it. So the same method we check for the testing set as well. We get all the nan and null, values, and we can do that. Okay, so we have another thing called train.describe. All these, you can check it out anytime, not a problem. It just gives us the mean, median, mode, and the 25%, 50%. This is the IQR interquartile range. It's called. So these are all different things, and this is the different features that we have, which are the only numeric features. Hence, it can give the values only for numeric features. All the other features that we had were features with objects in them. That means words as well as numbers or only words. So all those different kinds of things. And yeah, okay. So here also we have come across another important function called unique dot unique. So we have this data set here with a column called location, which has Mumbai, Pune, Chennai, Coimbatore, Hyderabad, etc., etc. A lot of different things. So what you okay? So if you all need, if I ask you a question that could you all list all the cities that are present in this column called location, you all would sit and go through every single cell and be like, okay, Mumbai is present, then Pune is present, Chennai, Coimbatore, Hyderabad, Jaipur, Kochi, Kolkata, all of these are present one by one, right? It's going to be a big headache. It's going to take a lot of time. So there's a function for that as well. So this Python function will return all the unique elements in the feature location, and the same goes for the other columns as well. So here it will return Mumbai, Pune, Chennai, etc., etc. Then fuel type you have CNG, diesel, petrol, LPG. So basically it just returns all the unique values here. Okay, and in the power feature we're checking all the null features, etc. Okay, so we can come to all of these later, not a problem. I just want to show you all how the visualization looks like. We can come here down. Yeah. So right. So here you have visualizations. We've come to visualizations section right here. Sorry. And yes. Okay, so this graph that you can see right here, so this graph basically is called a distribution graph. We are trying to understand the distribution of our data set right here. We'll come to all this in detail as well later. I'm just trying to show you the different visualizations that we perform. This is another distribution data, visualization. Then this is another, strip plot that we have right here. We are trying to get all the different values. And here you have a bar chart, different things. See all these kinds of different visualizations we have. And like I mentioned, we are doing one hot encoding as well. We'll come to that as well in future. So all of these different things we perform in visualization. Just want to show you what that is all about. Okay. So visualization, we've done model usage, model training. All of this is present in this Jupyter notebook itself. We can come to that. See. Right. So we've kept our training data set ready, doing all of the different data pre-processing. And yeah, this is also very important visualization that we have right here, which is also called as correlation. Okay, so you can see this word right here, CORR, which is called a correlation. And the visualization of this correlation is called a heat map that you can see. And if you all remember, we had imported a library called Seaborn, import Seaborn as SNS, and that library is used for visualization, like I said. And this SNS library we call in that the heat map function pass the correlation parameter and the different other parameters as well. The CMap basically means the color scheme that we use in this heat map. There is the blue color scheme and black and white color scheme. All different color schemes are there. You can increase the DPI also right here. DPI equal to 250 dots per inch. It will generate a more clearer image, look much more decent. So if you all remember, like I mentioned in a point right here called feature engineering, I had mentioned that there are columns in a dataset which prove quite useless and will not help in a model training. And it's best sometimes to get rid of these columns or features. And the correlation helps us in determining that which columns or which features is contributing the most to our output or target variable. Okay, so using this we understand which feature is very important, which feature is the least important, which feature can get we can get rid of, which is a useless feature, and etc, all of that. So that way we'll come to this as well in future, that in the next sessions we'll come in detail how it helps us, why it helps us, how it how do you do all of that. We'll come to all of it in detail in future as well. And here as well you have the heat map for your as well, training set, all of the different things. Okay, so here, like I mentioned, we have a library called sklearn, and we've imported an algorithm called extra tree regressor. So we're using this extra tree regressor algorithm for training a model and doing different things. And like I mentioned, this holdout is also an important method. It's very basic. Every person learning machine learning must be knowing it. And holdout basically means that you are dividing our data set into training data set and a testing data set. Okay, so basically we do is that we are dividing a data set into two parts, the training set and the testing set. So if I come to explain that, it will also take quite some time. It's very simple. Why do we do it? What's the output? How it helps us and all of that. I think it's best we'll come to that later. Let's finish what we are doing right now. So here we're importing linear regression as well. So all of this we see. Okay, so whenever you all read about machine learning, you all might be reading about the different algorithms that are present, like linear regression, logistic regression, neural networks, ANNs, CNNs, and all etc. different algorithms. But machine learning is not just about algorithms; it's about all of these different steps: extraction, data extraction, cleaning, pre-processing, etc., visualization, a lot of different things. So before the model training, testing, and all of that comes all of these different important steps. So one needs to be, knowing of all these steps as well. After that only you can do the training and testing and etc. different things. So you all might have seen every single algorithm might be having such high mathematical formulas. You all don't understand. It's pretty complex and all. It's complex. There's no doubt in that. But when you're coding as data scientist or machine learning engineer, it's very simple. There's nothing you need. There's just one line from sklearn library. import linear regression. That's all. You have the complete linear regression algorithm in your fist. You don't need to know any any mathematical formula very deeply for this as well. It's fine. So you're just using, what do you say, variable called linear reg to get the linear regression algorithm, and you're fitting our x train and y train variables in the linear regression, and you're creating a model for that, generating a model basically, you can say, storing it in linear reg variable. So the fit function basically is that you're training the model right here in the fit function. There is no explicit word as linear regression dot train, x train, y train. No. So you have the fit function which trains the model, and here you have predict function which will predict the values of x test. We'll come to this as well. We'll check what x train is, y train is, x test, y test. We'll come to all of that, no problem. And you can just predict the accuracy. There is a score, or there is one more function called accuracy score as well. You can try both. I'll tell you how it works. So you have all of this. There are different, what do you say, mm, errors. Okay, so basically you also have performance metrics, accuracy metrics or performance metrics in machine learning, where you are testing that how good the model is performing or how bad the model is performing. And these different metrics are like MSE, mean squared error, RMSE, root mean squared error, MAE, mean absolute error. You may have studied that, you may remember that in your previous years that you have studied in maths and all. And students who are in the first year right now, you all have M1, M2, you all might be learning different things in that. Yeah, so I just forgot to mention that point. All those who think machine learning is very cool, you'll enjoy a lot. Yes, you will enjoy if you have the interest, but be ready. Machine learning is completely, algebra. It's hardcore statistics, and the more deeper and deeper you try to dive in machine learning, it gets into calculus. So all that you learn in M1, M2, F3, it is highly used in machine learning. Again, I'm repeating, you'll need not know explicitly and deeply every single algorithm or mathematical step required in machine learning, but having a general idea will, prove a lot helpful while performing various steps or etc. different things. So when you're learning M1, M2, M3, just Google them, why it is used, where it's used, the different things. You will understand how it's used in machine learning, and hence you will have some interest while learning M1, M2, M3. M3 especially, it's a lot used. So these are different performance metrics that you'll have here that we use. We'll come to that as well later. And yes, so we did the model training, you do the model evaluation by running the performance metrics, getting the accuracy score, F1 score, precision, recall. These are the different performance metrics. You have another function called classification report, which again helps you all in determining the performance metrics. And some algorithms have values in them which are called hyperparameters. Sometimes when you tweak these hyperparameters, you get better results. So after you get the performance metric scores or accuracy scores, if you feel they are low and they can be increased, you all can tweak your hyperparameters a little bit more of models which contain or support hyperparameters, and that might prove in a more optimal model. And if you are doubtful if the current model that you are using, so if you are using logistic regression for classification, and you'll feel that okay, I'm getting an accuracy score of 70 to 80%, but if I use an SVM, that is a support vector machine, my algorithm score might increase to 90 or 95%. Then you all can use both these algorithms and check which is proving with a more optimal score. You all can select that. So there is the best model selection. And again, you'll run the performance metric scores comparison of the different algorithms like logistic regression, SVM, KNN, K nearest neighbors, etc. And then you'll have the inference determination. That means at the end, you will determine what did you all prove by running all of these different steps by generating a model. What did you all prove? So this is an inference determination. So all of that. And yeah, so like I've written here, what are different data sets I mentioned. Data could be used for training and testing the model, and it could be of various forms like numbers, text, audio, images as well. Like basically, you'll use Alexa, right? Google Assistant. In your phone, you'll have the Google Voice Assistant. How does it understand what you're telling it? It doesn't understand words, right? So yeah, basically it's a ML model itself that runs in the Google server at backend, and that uses audio, or it uses audio to convert into text. Then text is pre-processed into numbers, and when the computer will understand numbers, it will then understand, okay, what these numbers are fed to me, what output do I need to give, and then it will generate a certain output, and it will show you on your screen or reply as well after converting that text into audio and sending it back to you. So all of these different large and long number of sequential steps take place with every single command you'll place through your phone's microphone or Google Assistant or Alexa that you'll have. So this is a very basic example. And like I said, data sets could also be in various forms. The stored forms, the way it is stored, could be in CSV files, which can be opened with Excel. You'll have databases, which can be opened in MongoDB or different databases as well. And you'll also have JSON files. So if you all are aware of what JSON files are, you can just Google it, learn, understand what JSON files are. You all will come across it at some point or the other. So if you all see here in the CSV file format, you all have the columns and you all have the samples. But in JSON file format, you all don't have columns or samples. It's basically just like some words are written in curly brackets. So you'll have the name hyphen John, and then you'll have age hyphen 30, car hyphen null. So this shows that the column name is name and the sample is John. Column name is age, sample is 30, column name is car, sample is null. So like this is one line of JSON file format. You all will have 300, 3000, 3 lakh lines, one below the other, showing all the different values of JSON files. Okay, this is one another example of JSON file. So it looks pathetic, right? It looks really bad. But sometimes datasets are also in this same file format. You need to convert them into CSV, and then you all can use it. It will look somewhat like this after converting into CSV, and then you all can use it in the Jupyter notebooks for training and testing and inference determination purposes. So this is right here. You all have these are the column names, and these are the different samples that are there in the column. And another JSON example is somewhat like this. You'll have the curly brackets in that glossary. In glossary, you'll have title and etc. All of these different things. I just googled it to show you what it looks like. I had also used a JSON file format dataset once, but I cannot recollect where I have stored it. So yes, and yes. Now we come to what kind of data are found in datasets. So like yeah, test audio numbers, images, videos, etc. So yeah, images and videos. Let me come to that. Image that you'll see is basically just a frame. Okay, every image that you'll click in your phone, it's basically a frame, and when you'll record a video, it's a sequence of frames compressed very tightly that it looks like a video. Okay, so basically an image is just a frame, or a frame is just an image. Image and frame are two similar words, they have the same meaning. And video is basically sequentially compressed set of frames, so hence it looks like a video. And videos are pre-processed and predictions are performed, because at the end of the day they are images. They're just frames. So you can perform ML models, DL models, deep learning models, especially CNNs always, that you use for videos or images, and get the predictions or outputs. And their data extraction, okay, this is another important part. So when we come to the data extraction, there are various ways to extract data. You can either scrape websites to get the data, which is very, very tedious, takes a lot of time, and I wouldn't suggest you all to do that. It's not necessary. The other method you all can use is search for datasets already made by the different organizations. So there are various datasets available in the market and online. Okay, so let me know one thing. How many of you all actually, do competitive programming? How many of you all know what lead code is, hacker rank is, and all of those different things? Yeah, Naveen, we'll get the Jupyter file as well. It's available. I'll let you all know where you'll get it, everything. So just let me know how many of you all do competitive coding. You know, how many of you all know hacker rank, lead code, all of the different websites. Okay, so okay, assuming people know about it, excellent. So how competitive programming के लिए अलग HackerRank or LeetCode, for machine learning and deep learning models, you have something called Kaggle. So this is a website used for machine learning, competitions and all of the different things. So this website, it has all of these data sets. It has a lot of these Jupyter notebooks as well, solved Jupyter notebooks of all the data sets and everything. So you have different competitions right here with all of these different prices. You can have a look at it anytime. And you'll have data sets. So yeah, so example here, you'll have the chatbot data set. Let's just have a look at it. You'll there's a small description of what the data set is all about, the usage, everything is mentioned here, and see here, excellent. So this is a JSON file that we have right here, this data set, and it has different values in it. Okay. So see the value right here we have is the tag, string, patterns, responses, etc. So okay, so the tag that we have right here, okay, whenever you'll post images or anything on social media websites like Instagram or Facebook or anything, there are certain things called tags, hashtags that you'll use in that. So same thing right here, we have something called a tag, and the tag is a greeting. In the greeting, there are different patterns like hi, how are you, is there anyone, hello, good day, etc., etc. And the responses, these are the responses that are there. This is basically a data set that you'll have, and if you'll go to code, someone around the world would have solved this data set with their code. So see, updated 4 days ago, updated 5 days ago, someone just did all of it. And if you'll just click on code, you all will see the whole Jupyter file present right here. So this is a code block that you'll have, and this is the markdown block that you'll have right here. So the code imported NLTK, that is the natural language toolkit, another library used for NLP, that is natural language processing, basically the text processing that we do, and the different report things, everything is done here, pre-processing. So see, you all can just have a look at all of this. Kaggle is the best website to get all of these things. And when you come across a Jupyter notebook like this, if you all want to download it or something, click on the three dots here. There is something called download code or different options right here. Open in Google Notebooks. That is the Google Colab that I mentioned earlier. You all log in into your Google Colab. It'll connect your Google Drive. It'll directly this notebook will directly open in a Google Colab and all. You can do all of it. And the data set that's present right here. So you'll have one option called download. If you just click on it, it will start the download that you'll have right here in a WinRAR file, zip file. Okay, you'll extract it and you will get the complete data set of this JSON file right here. Various different uh, data sets are present with solved solutions, diabetes data sets. Again, small description, what the different features in the diabetes data set are, everything is mentioned here. And this is the data set present right here about the file, and this is the data set. Every single feature is present right here. You can just download, it'll download. Or if you want, you can go to code. So you'll have 209 people that have solved this data set with everyone's, their own different kinds of inferences. You can just open anything. XGBoost, CATBoost, all these are different algorithms that are used. Just open anything, whichever you find suitable, download, run, understand every code block, code cell, what it is, why it's used, etc. You will get a hang of it with time. Okay, solve more and more, you will understand it better. So data extraction, I told you where you'll get the data sets, where you'll get the solved solutions as well, and why do we need to apply different algorithms for data munging? Yeah, like I mentioned, for the data cleaning that we have, let's look here. Mm, for the data cleaning, mm, okay, right. So data cleaning part, let's just have a look at it. Since I mentioned it, we'll just go through it quickly. It won't take much time. And we have a feature called your power bracket BHP. In that, we have a lot of values with null. That means There is nothing present in it. It's empty. Okay, it's a null value. This is the train right here. Yes, train. And we have the column right here of power PHP. And many of these values seem null. Okay. Okay, so let's just look at it. We have the feature that here of Power PHP with a lot of null values present in them, null PHP. At the 76 sample, we have null PHP present. We'll just look at this. 76 sample, right here, 75, 76. Okay, right here. 78, we have the null PHP. 81 again, another null PHP. So all of these samples that contain null PHP, we just printed that. And how to tackle this problem? So if you just look at it, you have train dot location is equal to Pune. Okay, we will perform one not encoding different things. Uh, okay, right. So what we do is that in the dataset that we have the samples which contain null BHP, we get rid of those samples. So all of the samples which contain the null BHP, we are getting rid of those samples because there are different methods that you can use. You can either delete the samples which contain null values in them, new price, power PHP, etc. Or new price, the whole feature is itself an empty feature, it barely has any values in them. So delete this feature itself, it's of no use. But power or PHP, power PHP, some values contain null, not all. Hence, I can either tackle this problem by deleting the samples which contain these null values or fill those samples by using the average value of this complete feature. So assume in this feature the average values may be 4, 5 or whatever you say, 18, 20. It will fill most of these features with the average 18, 19, 20, whatever. Maybe all of this would get filled with 18, all of this would get filled with 20. So the average value would replace the null values present in here. Or you can use median, mode, any of this. So yeah, so this is basically the way you tackle different problems like data pre-processing. And yes, I'll share this notebook as well with all of you. You all can have a look at it. And like I mentioned, you all can always go to Kaggle and find all these different data sets. So if you all just type used car prediction, I'll just show you all. See, I love your so see everything, diabetes prediction, everything is present. Used car prediction. Again, you'll have the data set right here. I think I downloaded the data set from here itself. It'll all have the same values. Mileage engine, whatever. Then you'll have the code, solved codes of this data set. You can have a look at it as well. So all of this is present right here. You can do all of it. So yes, guys. So basically, this was today's session. We checked all the different things that are used in machine learning. The basic steps, we saw all of it. And the next session, we'll start having a look at the different algorithms one by one. That is in the data munging or cleaning process. What different cleaning processes do we have? What algorithms do we use? How do we clean it? We'll have a look at all of it in detail from the next session onwards, and sequentially we'll go through all of the pipeline steps and check everything in detail. Then in the end, we'll reach the algorithms, how those algorithms are. We'll come to the performance metrics and everything. And slowly, then we'll come to the deep learning section as well, where we'll come to neural networks, the artificial neural networks, recurrent neural networks, convolutional neural networks, and different things as well. So, yes, so any questions, guys? You all can unmute or type in the chat box. Anything. Yes. So I don't think there are any questions. I hope everyone understood. Okay, Yatnish. So yeah, we have a question right here: is how images can be converted into datasets? Good question. I'll come to that. Okay. So I think when we'll come to the second year, we'll come across a subject called computer graphics. Okay, so that computer graphics subjects, you'll need to just pay close attention to that subject where you all will understand how images actually look like. You'll have different channels in images like red, green, blue. You'll have different values ranging from 0 to 255. So how those values are stored in data sets, you might get a decent idea when you'll look at concentrate on the subject called computer graphics when you'll come in second year. But anyways, I'll also come to that in future. And yes, I'll let you all know how it is. And then Naveen has asked us another question like ML versus SQL, which is better? So Naveen, I am the question doesn't seem very specific. It's okay. So what I've understood from his question is that machine learning versus SQL, which is better? Machine learning is a domain, and SQL is a language. See, okay, SQL is just a language. SQL मतलब databases. You use databases while learning machine learning. So I don't understand machine learning versus SQL क्या होता है? I don't know that. Right. So yeah, Ishita, is there any software tool which can annotate the large image dataset? Yes, so you have a library in Python called label image. Using that, you can annotate the complete data set manually. But if you have an extremely large data set, it's going to consume a lot of time annotating it manually. So sometimes there are Python programs available where you can, the annotation is done itself. You give a base annotation to the model. The model will try and learn from maybe 10, 15 different images, and it'll start annotating all of the other images by itself. But usually, I don't think that would be a problem because all the datasets are already available and you won't need to annotate much of the images. Or, for example, if you're just trying to create your own object detection model, which is trying to detect your own objects around you, then you can just click different photos of it 10, 15, 20, 30, 50 photos and annotate them manually. So that won't be much of a problem. And the library used for this annotation is label underscore img. You can Google it and you'll get it. Yes, any more questions? Sure, Ishita, sure. Okay, guys, please let me know if there are any more questions. We'll, clear the doubts and then we can end our session. So when you all can get free, I know you all also tired after a long day in college. Okay, great. So doesn't seem like there are any questions left to answer. So thank you all, guys. Thank you so much for being through the complete session. I hope you all understood most of the concepts. And if not, drop me a TM or WhatsApp or anywhere you all wish. I'll try and clear the doubts, whatever are there. And okay, so thank you so much, guys, for attending. We'll meet in the next session. I'll let you know when the next session is. Okay. Thank you so much, guys. You all can leave the session. Thank you, Aditya. Thank you, Yadnesh.